This is video number 3 for chapter 7. In this video, you are going to learn how to write names for ionic compounds, and it would be very helpful for you to have your periodic table and polyatomic ion pink sheet handy when you're doing this video. So have those things available. Now, the first thing we want you to be able to do is in your formula, you're going to look at the formula and you are going to determine the cation, the one that is positive, and the anion, the one that is negative in the formula. Now, you're basically going to learn that compounds have two names, a first name and a last name. For the first name, that fits the cation. Okay, that's the positive part of the compound. You just name the element, that name will stay the same. It goes first, and if you have a transition metal, you will need a Roman numeral to indicate the charge that that transition metal has. In addition to the transition metals needing Roman numerals, so will tin and lead. And then there are 3 transition metals that will not use Roman numerals, and those are silver, zinc, and cadmium. And the reason behind that is silver is always a +1, zinc is always a +2, and cadmium's always a +2. There's no variation in their charges, so there are no Roman numerals needed. So you name the cation by naming the element name. If that element is a transition metal or tin or lead, you'd use a Roman numeral. The anion, the negative part of the compound, is named 2 different ways. If the anion is a single element, like chlorine, you will change its ending to chloride. Chloride would become the new name. If the element or the part of the compound that is negative is a polyatomic ion, you just keep the name the same. So let's work through some examples. And the first example I'm picking is one that I know you all could name without me teaching you anything first. Okay, so NaCl, my guess is most of you know how to name that compound already. But let's use what you know to teach you the process. So what I always want students to do is figure out what's the positive part of the compound, and then everything else must be part of the negative. So in this compound, Na, or sodium, is the positive part of the compound, and that means Cl must be the negative part. Now, for naming Na, since it's sodium, the name will just stay the same. So I will just write sodium. Make sure you spell it correctly. You have a periodic table. And then chlorine, I will take, since it's a single element, I'll just change its ending from chlorine to chloride. Okay, so most of you knew sodium chloride. Now, on the next example, I'm going to give you this formula, SRS. Again, I want you to identify the positive and the negative parts of the compound. So Sr is the positive. That means S must be negative. Now, looking at this compound, Sr is strontium. So you'd go to the periodic table, find its name if you didn't know that one already, strontium. And S is a single element, sulfur. We're just going to take the ending and change it to ide. So instead of saying sulfur, we're going to say sulfide. One more example of this type of problem, and the next one will be K2O. Now the positive part of this compound is potassium, or the K, and that means oxygen is the negative part. So to name this compound, I'm going to say potassium. I keep the first name the same, and then oxygen will become oxide. Now these three examples are all parts of compounds that are called binary. Binary compounds have 2 elements in them, and if you'll notice, they all end in I. Now to do some more examples that are not binary, these will involve a polyatomic ion. Let's try something like Rb2SO4. Okay, again, find the positive part of the compound. The positive part of the compound is the Rb. That means everything else must be part of the negative. So in this case, the SO4 is the negative part of the compound. Now with the positive part of the compound, Rb, looking at your periodic table, you're going to figure out that that is called rubidium. Now, the negative part of this compound is more than one element. It's a polyatomic ion. And so you're going to look at your pink sheet, and you are going to... Sorry for the interruption there. Anyway, you're going to look at the pink sheet, and you're going to find that SO4 is called sulfate. So you are just going to leave that polyatomic ion name alone, and just name the first part of the compound rubidium. The second part of the compound is sulfate. So the name of this compound is rubidium sulfate. If you notice, of the 4 examples I've done so far, everything just has 2 names. So compounds should have a first name and a last name. Let's try something that involves a transition metal. Okay, so on this one, we're going to use Fe2, let's do S3. So on this one, the positive part of the compound is the Fe. That means S is part of the negative. So Fe is called iron. Now you'll notice that iron lives in the transition metals. So we're going to use a Roman numeral to indicate the charge. That Roman numeral gets written in parentheses. So I'm going to draw the parentheses there just to remind me to go back and figure that out. Now this S is a single element, so I'm going to just say sulfide. Oops, sulfide. And now my job is to work backwards to figure out what the charge on the iron is. I don't know what it is right off the top of, just by looking at the formula. So my advice to you guys is draw what you see in the formula. We know we have 2 Fe's in this formula. We know we have 3 S's in this formula. And we know that the total positive charge has to equal the total negative charge. Now we do know the charge on sulfur. Looking at the column that it lives in the periodic table, we know that it's a -2. So if each sulfur has a total charge of -2, that would add up to be -6. That means this compound has to have a total charge of +6, which means each iron has to be a +3. So I would put the Roman numeral 3 in that parentheses. So this compound would now have a name of iron 3 sulfide. Let's do one last example. This time I'm going to give you Cr3 parentheses PO4 parentheses 2. So these formulas can get more complicated, but keep following the same rules. In this one, what I want you to do is find the positive part of the compound. That's chromium. That means everything else must be part of the negative. Okay? So the first part of the name is the positive part, chromium. When you look at where that lives on the periodic table, you're going to see that it's a transition metal, which means that it needs a Roman numeral as part of its name. And the PO4 is a polyatomic ion, and when you look it up on your pink sheet, you'll find that that is called phosphate. So your only job is to figure out what the charge on the chromium is. So now what I want you to do is think of the formula again. Draw how many chromiums are in the formula. This time there are 3 Crs and there are only 2 PO4 ions. Now the PO4 ion each has a charge of -3. So when I add that together, I get a total of -6. That means this has to have a total of +6. So each chromium must be a +2 to get that to work. And so I will have a Roman numeral of 2 for that element. So this name of this compound is chromium 2 phosphate. All right, I think hopefully that is going to cover how to name ionic compounds. And so you will have a learning check to do the next time you're in class.